I'll put a link in the description where you can buy this module. Just watch out because there are two versions, one upgraded one and one which is not upgraded. This is the upgraded version, and this one is the one you want, that it will allow you to like power your circuit while charging the battery and offer all these protections. The only thing you have to check when you buy this basically is that this little black IC here is the IP5306 and not the CD42. And usually they have to board a black one and a white one. The white one is the upgraded one, but you can also see it from the price eventually because the upgraded one is a little bit more pricier. I think this module is like $1 or $2, something like that. Hello YouTube, long time no see. If you remember my last video, which is now like a couple of years old or something, I showed you how to use these two components, like this power module and this voltage booster, to like power a circuit and charge the battery at the same time. I got a lot of questions about that video, but now I found another solution which is way more like elegant, which is this module right here. This one will replace basically everything you saw in that video, and it will allow you to power your circuit, whatever it is, Raspberry Pi, motor, whatever, while charging the battery. It also offers battery charging protection, discharge protection, over voltage, under voltage protection. So it can basically replace these two components and also this protection module for like batteries potentially, which is a way more compact solution. It's also very easy to use. We have the input and output here. This will be your 5-volt output, so your circuit, it can be a motor, Raspberry Pi, whatever you need, positive and negative. Then we have the battery, positive and negative, and then we have basically the power cable that charges everything. This is the negative and this is the positive. We also have a battery indicator here, which you can activate by pressing this button here, and you'll get like basically 55%, 50, 75 and 100% of the charge of the battery. And if you want, you can also extend this little bottle by connecting another button to the keypad here. And then you will put basically a wire here that goes to the button, and then the button you connect it to ground. And every time you press the button, it's the same thing as pressing this one, but you can kind of decouple it. Just one thing I didn't mention here, the input will be 5 volt. The battery has usually 4.2 volts when it's fully charged, and we will have an output also with just the battery connected of 5 volts. Before testing this, maybe let's have a look at the datasheet real quick. Okay, so there are two datasheets. This one, it's the most Chinese one. The only information it has that it's a little bit more simple to comprehend, it's this one. Built-in power path management supports charge while discharge, which is exactly what we are interested in. And this is the other one, which is a little bit less Chinese and it's a little bit more comprehensible in my opinion. So let's check the main feature real quick. Synchronous switching charger, 5 volt, 2.4 amps boost converter, support multiple battery types, 4.2 to 4.4 volt, multiple protection high reliability, output over current, over voltage, short circuit protection, input over voltage, over current, battery overcharge, over drain, over current protection, thermal shutdown. So here are the table in which we are interested. Input voltage from 4.65 volt to 5.5 volt, DC output voltage, V out 3.7 volt, 5, so I guess yes, with 3.7 volt in the battery we have an output of 5 volt. Battery standby current, VBAT, yes, so I guess it will try to keep the battery at 3.7 volt or something. And here we have what I was talking about before, so by adding a button to the keypad and connecting it to ground, we can basically have an external button
acting as the button on the PCB. And here are the functionality of this button. Feel free to pause if you're interested in them.
And now for testing this, I'll use the setup of the previous video. We have our load or circuit, which will be this little motor here, with the PWM controller, and then we have the battery, which is exactly the same one as in the video of like 2 years ago. I'll show you how to connect everything, and we can then test that this actually charges this battery up to 4.2 volts and not like beyond that while the motor is still powered. Okay, so now almost everything is connected. If we press the button, we can turn on the board and we will have 5 volts on the outputs. If we want to turn off, we double click it. Or if we turn it on and then we wait for 30 seconds and it will not detect a load of more than 50 milliamps, I believe, it will automatically shut off the output. There we go. It will also automatically detect a load if it's more than 50 milliamp. Now if we connect the output to the motor and we turn it on, you can see it automatically detected the load and it started by itself. Now we should have 5 volts on the output, which seems to be the case. The battery should still be around 4 volts, more or less. 3.84. If we now attach the power cable, you can see the LED is blinking and it's signaling the charge. The motor is still also working. And if we disconnect, we have like a slight loss of power. A little drawback from this little module here is when you connect the charging input to it, we get only 4.5 volts on output, but we can fix this with a buck boost converter. One important thing is if the power cable for the charge is connected, the button will be disabled. So now I completely run this thing dry so that it won't turn on anymore. We can check the battery voltage real quick, which is about 0.37 volts, and we can try to charge it and see how it goes. So battery chargers, this is the positive wire and the negative. So we can see LED indicator is on the lower side, so the battery has been completely drained. The motor won't turn on probably because the battery is like below the security threshold. 2.189 volt, 2.2, and rising fast. And now we'll see how long will it take for it to start spinning the motor. Oh, there we go. It's already started. 2.5 volt. We have 4.2 volts on the output of the board and 4.3 on the motor. So we'll let this charge and we'll see if we go over 4.2 volts. So it doesn't seem to charge the battery beyond like 3.8 volt while the motor is running. 3.805. So it seems like 3.8 volt, it's like the limit while the motor is running, which according to the datasheet should have been like 3.7 volt or something. I guess it's not going over this. And yeah, so far everything is going as advertised. I'm gonna try to shut off the motor and see if I can charge the battery a little bit more and if it's going over 4.2 volts. Alright, so I left this in charge all night with the motor off. Now let's see the voltage. Nothing has exploded so far, so I would say it's a big success. 4.13, that's okay, I guess. And if we turn it on, it should start diminishing up to 3.8 or something. Which it seems to be doing, so I would say this works as advertised. The only downside is that 4.5 volt when power is connected to the module, but we can fix this with a buck boost converter.